So here we're going to go through a current drift velocity example. A copper conductor of square cross-section 1 millimeter on a side carries a constant current of 20 amps. The density of free electrons is 8 times 10 to the 28 electrons per cubic meter. Find the current density and the drift velocity. So we're after finding the current density, which is J, and the drift velocity V. Well, we've got all the information we need here. We know that the conductor has a cross-sectional area of 1 millimeter, and it carries a constant current of 20 amps. So we've got the I value, the density we're given. So it's quite easy. First of all, let's just convert the millimeters into meters. So that's 1 times 10 to the minus 3 meters. And the area then, 1 millimeter squared, turns out to be 1 times 10 to the minus 6 meters squared. So we've got the area in the standard SI units. So the area is 1 times 10 to the minus 6 meters squared. Now the current density in the wire is 20 amps divided by that area. So that's easy. We just plug in the values and we end up with 20 times 10 to the 6 amps per meter squared. Now remembering that the current density is really this equation that we had. Remember we had I over A, which is current density, but it's also the number of electrons per cubic meter times the charge times the velocity. So if we just take one of those, as we explained in the last example, we just take one of those then and then place in these values. So we've got the current density. We can rearrange that for V. As we've got the current density, we've got the charge, and we've got the number of electrons per cubic meter. So let's plug these in and see what the velocity is in this example. So with these values plugged in, we find that the drift velocity is 1.6 times 10 to the minus 3 meters per second. Well, that's interesting. Or we could easily say about 1.6 millimeters per second. It means at this speed, an electron would require 625 seconds, or about 10 minutes, to travel the length of a wire 1 meter long. So that's a really slow drift velocity. So when we're talking about current moving through wires, you've got to remember that the individual charged particles themselves move very slowly. The drift velocity is very slow indeed. So that's a really good example of showing quite clearly how slow these charged particles will move through conductors.